This is for my informative speech about turbos. Here are two people here, one person there, and three people here. That's not muted, guys. My name is Chandler Hartz, and this is my informative speech about turbocharging. So, first I will show you how a turbo works. Exhaust from an engine will flow into these holes here and collect into this log and enter into this snail-shaped housing into the back of a turbo. It'll then spin a small fan inside here, which will then turn a shaft which goes through both of these and then into this side, which will suck air into this hole and force it out of this hole into the intake of an engine to add boost. So that is how a turbo works. And now I will show you the history of turbos. And the first introduced factories were in the 1900s by General Electric, and that was said by TurboSmart on September 19th, 2011, and they were interested in aviation use for the turbos. And they were so interested in using these for aviation because at high altitudes, like this plane would fly here, they needed denser air. Because at high altitudes like this, the air is thin, and they need denser air for high performance out of each engine. So if this plane here did not have turbos, it would need twice the amount of engines to stay and fly at the altitude they were flying at. So now I will tell you about more history of turbos in vehicles. So the first production car with a turbo was in 1962 in an Oldsmobile Jetfire. That proved to be very helpful for fuel economy and performance using a smaller engine compared to a larger displacement engine. It was able to use less gas and keep up with similar engine power numbers as non-turbo vehicles. And then, since then, turbos have advanced their engineering in their size, in their fan rotation, in the fan pitch, and then in cooling through air, oil, or water. And then they've also changed different technology in the bearings spinning the fan inside the turbo. So then I will tell you about the three benefits of a turbo. First, you have performance, then fuel economy, and then third, you have noise canceling. So first for performance, on July 30th, 2014, Miguel Isaza said, an engine in essence is an air pump. Air mixes with fuel and goes bang, and then it leaves. When talking about ways to make more power, it is obvious to make a bigger bang. Gasoline needs a very specific mixture to make that bang. It is 14 parts air and 1 part fuel. So if you want a bigger bang, you need 14 parts more air to add 1 more part of fuel, which is why turbos come in so much handy, because it adds specifically more air to the engine in good fashion. So, when you add that air to the engine, it puts less wear on it because it doesn't need to work as hard to suck the vacuum in to get air into the motor. It is then forced and induced into the engine, so it is easier to introduce fuel and air at the same time. And the second would be fuel economy. So the amount of power a turbo would help an engine get is equal to a larger displacement engine. So a larger engine without a turbo and a smaller engine with a turbo would then in turn have similar performance while using less gas and less performing parts. You can get the same type of power out of it. So then we also have noise canceling. So a turbo works as a revolving door. Exhaust would flow in through the manifold here and then into the turbo. So each piston pulses into different times in each cylinder. So the pulses are very loud. So the turbo acts as a revolving door with the fan in the back here. So the turbo air comes in and then it uniforms it into one solid flow to make it more quiet and uniform. So no pulsing. And that helps it noise cancel, which also makes it more efficient because some of the excess energy lost in an engine is heat and sound. So the turbo is therefore recycling energy that the engine cannot use anymore. So it uses used exhaust air to push new fresh air into the turbo. And by using the rest of the energy, it makes it quieter and more efficient. And lastly, I'll talk about the other places you can find turbos where you may not think they'd be. So now you can look around while driving and you can 9 times out of 10 see a car on the street next to you that has a turbo or uses 1 or 2 turbos even. So they've showed that much performance and efficiency that they have become almost standard on every automotive brand out there. And you can also find them in different places as in airplanes, like the one I showed before, at the high altitude and thin air. And you can also find it in equipment. So forklifts, tractors, and semi-trucks are almost all standard with turbos because they are more efficient. And as Alan Jay said in 2018, it lowered fluid temperatures, making the engines more reliable and caused less wear and tear overall. This is very important for these engines because they run very long hours non-stop. So they need to keep temperatures low so they can run as long as possible and as most efficient as possible. And these have also been found common to do very well in large boats, and their large engines pushing these boats across the ocean to keep them more efficient and performance-wise do better. And now that I've informed you about turbos, you can educate your friends or talk to your local mechanic about a turbo engine. Thank you. Here's my audience, still here. And here are the other 3. Thank you.